Lesson 43 and 44. Trigonometry.
Is it spelled?
Welcome to trigonometry.
Thank you.
New concept.
Love you too.
I'm gonna go cry.
Might be a scary sounding word.
It is scary. It's a
What you
big one.
suppose try means?
3.
4.
Okay. And GONO, that's for
Angle, gone.
gonon, which is yes.
Shape.
Yeah. So 3 angle.
So it's
So
like
what do you suppose that this?
Math.
What do you suppose that trigonometry is about?
triangles.
Triangles. Metry in English words, if they end in metry like that, it usually comes from the Greek word metron or metros, meaning to measure. So trigonometry is all about triangle measurements. We're talking about triangles. And the vast majority, actually all of the trigonometry that you're going to be doing this year, and probably for quite a bit after that, has to do with not just any triangle, but specifically right triangles.
Just this easy one.
You say that now.
Well, because it's Pythagorean theorem. And with a right triangle, you already have one of the angles.
Pythagorean theorem.
Okay, so if I draw a triangle, a right triangle, and that's not going to show up very well.
Green.
Blue. Agua.
Agua. Water.
Blue's first.
Agua.
All right, let's say we've got a right triangle here. You know it's a right triangle because of my awesome artistic skills,
Yes. And the circle.
which means this little square thing here. All right, so this would be a right triangle. Let's call this angle A.
Oh, yeah.
Okay, capital A.
Yeah.
Now, do you know the names for the sides of a right triangle?
Oh.
Yes.
The big one, the really big one is the hypotenuse.
That's right. So this one's the hypotenuse.
Hippopotamus.
They have
So you got the easy one. Good. What about the other ones? You know what those are? Okay.
Acute noose.
Acuteness.
Yeah.
Well, this would be an acute angle because it's less than 90 degrees. Depending on where you read and things, a lot of times the other two sides of a right triangle are just called legs. But there's no good way to, leg. There's no differentiation between them. Yes.
leg, hip.
Sure.
Because the legs go into the hip.
Now, if I'm talking about this angle right here, remember what the word? You know what the word adjacent means?
Yes.
No.
Near, next to.
Yeah.
Over.
Kind of near, but mostly next to or
Touch.
touching, right? So of these other two sides, the hypotenuse is always the long side of the right triangle. Of the other two sides, which one is adjacent to angle A?
The bottom leg.
Bottom.
This one right here.
The bottom
So
leg.
I'm going to call this the adjacent side.
Adjective.
And this side over here, where is that from relative to this angle? Where is it on the triangle?
Not adjacent.
That's right. It's not adjacent. It's on the opposite side of it.
The oppo.
We're
OPO.
going to call this the opposite side.
Or not. Okay, not OPO.
Okay. So we've got this angle A, and the sine, S-I-N-E, abbreviated on the calculator with S-I-N. What the sine is that's a relationship. It's a ratio relationship of sides of the right triangle. So trigonometric functions are ratios of sides of a right triangle. That's nature. Okay. So the sine of angle A, that is the opposite side divided by or over the hypotenuse. All right. So if you take whatever the length of the opposite side is, and you divide that by the length of the hypotenuse, that relationship is called sine for this angle here.
Yeah.
So there are three aspects to this relationship. There's an angle, and then two sides. All right. Now there's another relationship called cosine. Talking about the same angle, the cosine of angle A abbreviated COS. That one is the ratio of the adjacent side over the hypotenuse. Okay. So if you have a right triangle, we're talking about angle A, the ratio of the adjacent side, however long this is, divided by the length of the hypotenuse, that is called cosine. Question?
Why would you use cosine instead of sine? Or are we just going over the terms?
Yeah, we're going over the definition of the terms.
Okay, because I was just wondering, when do you use them?
Yep, we'll get to that in a couple minutes. All right, and then another important relationship is tangent. When we're talking about angle A, the tangent of angle A, abbreviated tan, that ratio is the opposite side divided by the adjacent side. You need to memorize this. This stuff right here.
That's why you're drawing a box around it, right?
Yes.
Wait, let me write it down.
So definitely need to. So you need to memorize this. There are a couple of common ways to do this. In this book, go ahead and finish.
You barely made it.
That's what you were doing? You were tearing up a piece of paper to get a little piece to take some notes on?
Why didn't you just tear a little piece off?
There was always stuff on paper.
Wow. All right, the way this book, since you need to memorize this, it'd be useful to, like memorizing anything, it's useful to use a mnemonic of some sort, some kind of memory device, some thing that you can, that will make memorizing this easier.
Quizlet.
You always do, people always say it's sine, cosine, tangent. They always say it in that order. What the book suggests is to use a sentence made from an acronym. First letter of this side is an O. So the book says that Oscar had a hold on Arthur. Right? O and Oscar for opposite, had H for hypotenuse, A for adjacent, H and hold for hypotenuse, O and N for opposite, A and Arthur for adjacent. Oscar had a hold on Arthur.
Yeah.
Okay. Now that's what this book suggests. Almost every other math book uses a word. SOHCAHTOA. You say it? SOHCAHTOA.
What?
The idea is, and it's spelled like this. SOHCAHTOA. And what this tells you is that the sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. And the tangent is the opposite over the adjacent.
I like the SOHCAHTOA better.
I think most students do, but some people remember Oscar had a hold on Arthur better.
Yeah, I won't.
Pick one. Pick one, and whatever works for you, do that. Because you do need to memorize that the sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Okay. All right. Now, what are we going to do with this? We're going to use this, and you have your calculator, right? In degree mode.
Degree, yeah. Degree mode.
Let's pick something else.
Green.
Agua.
All right.
How do I say green?
Let's say,
Yay.
let me, before I forget here.
What do you mean overflow? Doesn't make sense. Transfer.
No, I'll come back to that in a minute. All right, let's say we've got, let's do some triangles here. Let's say we've got a right triangle with this angle A, and this side is 4, that side is 7, This side is 5.74. What is the sine of angle A? Well, here's angle A right here. And sine is, actually, you don't need a calculator for this part yet. And sine is, what the relationship for sine is the opposite side over the hypotenuse. So in this triangle here, relative to angle A, the opposite side is this one right here, the 4. So that's going to be 4 divided by the hypotenuse, which is 7. So whatever this comes out to, whatever that comes out to is the sine of angle A. What is the cosine of A?
5.74 over 7. If that's
right. Because for this angle here, cosine is adjacent over hypotenuse. Adjacent is the side next to the angle we're talking about. Since we're talking about angle A, the adjacent side is the one side next to it. That'd be 5.74
It's not the hypotenuse.
over the hypotenuse, which is 7. And what's the tangent of this one? What's the tangent of angle A?
My calculator to do it. It's
4
4 over 4.
five.
Yeah,
The opposite side,
4
which is 4 over the
over
adjacent side.
5.74.
Okay. Now, that's all fine and good,
What? No, you're.
but we still don't know what angle A is, right? We don't know how many degrees angle A is. All right, the trig functions, sine, cosine, tangent, you plug in you plug in an angle, and the calculator will give you a number. So if you know what the angle is, the calculator will give you the number.
What's like
Returns
cosine?
a number. All right, so it takes a number, gives you or it takes an angle, gives you a number. What if you know what? Let's say that you already know that the cosine of angle A is whatever decimal number this comes out to. All right, let's do this one. Let's say that you know that the sine of angle A is 0.571428. Right? Let's say that you already know what that number is, and you're trying to find out how big is angle A, how many degrees is angle A. Well, that's where we use the inverse trigonometric functions. And
Right.
so the inverse trig functions. Right next to the camera. That's really sensitive microphones.
Hi, people listening on the internet.
The inverse trig functions is when you plug in a number,
Like the
you plug in whatever the number is, like whatever number the ratio gives you, or the ratio is, and it will tell you what the angle is.
So wait. So that's like the sine but -1.
Okay, calculator returns the angle, and so the trig functions, that's sine, cosine, tangent, right? With those abbreviations.
Yeah,
The abbreviations for the inverse trig functions,
are the same with the -1.
yes, sine with a little -1,
And
COS with a little -1, and tan with a little -1. So let's say we've got this relationship here. In that triangle, we know that the sine of A is 4/7. If we want to find out what the angle is, the same relationship between angle A and the side that is 4 and the side that is 7, I can say if I do that 4/7, if I take the 4/7 and I do the sine minus, or the inverse sine of that, if I plug the 4/7 into the calculator using the inverse sine function, what the calculator will tell me is the angle. So now what do we got on the calculator?
34.84990458.
34 point what?
84.
84? Okay.
990.
Okay, so 34.85. We'll round it off to two places.
Yeah, sure. Why not?
34.85.
Is that what you want us to do?
Yeah, so now that we're using trig functions on here, it's going to convert things to decimals, and so just round everything to two decimal places, and that's good enough for this class.
Okay.
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 So,
Sin cosine.
based on this relationship, I can't plug this into the calculator.
Yeah.
Right? Because you can't tell your calculator, hey, what's the sine of an unknown angle? The calculator can't do that. You
Hey,
know,
Siri,
We can
find
put in the angle.
Ask Siri.
Hey Siri, find me the side of.
you people. All right, now just to make the point.
Oh, can we ask Siri and see if she can do it?
Just to make the point, what is, now that we know that angle A is 34.85 degrees, on your calculator, do the sine of 34.85. And you should get something close to 0.57.
0.57142998.
Exactly. In this same triangle, right, this is angle A.
Yes.
Let's call this other angle here angle B.
Of course.
Just pick a letter.
So then the
Is
adjective
this side still the hypotenuse?
definitely. Most
Yes.
definitely.
Yeah, this side is still the hypotenuse.
We try not to rich do
Now, which side is adjacent to angle B?
the opposite side.
The opposite side.
The
That's
The
opposite
now.
one
side.
that was the opposite side.
This one here is now, if we're talking about angle B, this side is the adjacent.
You just write it above the adjective.
And this side over here is on the opposite side of the triangle from angle B, so if we're talking about angle B, this side over here is the opposite.
Angle B.
Right? The hypotenuse is always the hypotenuse, but the adjacent and the opposite depend on which angle you're talking about. I would say if this is a 24-degree angle, this angle up here is B degrees. This side is H, this side is Y, this side is 9.5. Alright? Easy one. What's B? Or how do I find B?
You would add 90 plus 24 and then subtract that sum from 180.
66. B is 66.
That's what I
Because
said.
180 degrees in a triangle, we know this is 90, we know this is 24, so 90 plus 24 plus B is 180, and that's going to give us B. Excellent. All right.
Green. Purple.
Black. You heard of black.
I didn't actually, sorry. All right, let's solve for, let's solve for H. I want to solve for H. What other side do I know?
9.5.
I know 9.5.
Which is the adjective.
And we're talking about this angle here. So which of these relationships for the 24-degree angle
Cosine.
involves these two sides?
Cos.
That would be cosine.
Cos.
And which one goes on top?
The 9.5 over 8. It's 9.5 over 8.
The adjacent side, which is this one here, over the hypotenuse.
Yeah.
And hopefully you remember from before when I said when you are setting these problems up,
Put it over 1.
the best recommendation that I have for you is to put that over 1 and then just treat it like a proportion where you cross multiply. 1 times 9.5 is going to equal H times whatever the cosine of 24 is.
Which is 0.91.
0.91.
0.91.
Right?
0.91.
Okay, divisible sine of
345.
0.91. Cancel, cancel, and H equals
7.
what?
Wait, what was it?
What's H?
9.5 divided by
9.45.
10.439560.
10.44.
Okay.
A.
And with anytime we're doing these trigonometric functions, sine, cosine, tangent, the round things to 2 decimals because depending on how you type it in, you're probably going to be a little bit off. If we're a little bit off on the hundreds place, that's completely fine, totally expected. Okay. Now, so that's solving for H. Now let's solve for Y. So same 24-degree angles. Now we want this side is the one we're looking for, and we know this one here.
Tangent.
That would be, the relationship there is tangent. Tangent 24 degrees is which side?
Tangent of 24. Oh, it's the opposite,
Opposite side,
over
which is?
which is y.
Opposite side
Over
is y.
9.5.
Over the adjacent side, which is 9.5.
The tangent
So
of
the
24
answer
And
is
again, put this over 1, so you
0.45.
cross multiply. 1 times y is y. And then we have 9.5 times the tangent of 24, which is
0.45.
0.45. Therefore, y is
4.23.
7.
4.24 then?
9.5
Did we round it to 2 places?
Yeah.
times 0.45.
I'm taking your word for it.
No, 4.23.
4.28. Yes.
4.275.
4.27, 4.24, 4.28. Notice
4.28.
we're just a few hundredths off. I would not mark you wrong if you had this and the book had 4.28.
Oh, well, I got the direct answer for the tan of 24. So that's what I multiplied, so it was a little.
If you just round
Yeah,
it,
we'll
then you would
dig
get
in for
the
you.
correct answer that's like exact in the book. So if you just round it, yeah, because if you round it, you get 9.5 times 0.45.
Actually, the actual answer is 4.23.
Oh my
Or what I said.
gosh! But it's not. It's not.
That's what I said.
Drop it like it's.
I'm so confused.
Because you just
See,
do
because what I did
you do
was
tan of,
I did the tangent of 24,
and then
and I left the full decimal on my screen times
times
9.5.
and it's 4.22967
Dot.
4.2296725.
Alright, very happy. So y is 4.28
Or close.
or 4.23 or something close to one of those answers. In any case, it's not 423. Let's say we've got, this is 44.2. We've got a triangle. Let's call this angle 35 degrees, this angle b degrees, and this side is m, this side is x, and this side is 14.
Oh, okay.
What do you want to solve for first?
Well, we can solve B easily. Wait, can I can see it?
Okay. Yep, because 90 plus 35 plus b is going to be 180. That's going to be
So 90 plus 35 is 125. So, I'm gonna show you how. So it's 55. And then
B is 55.
we can do 14.
All right, now. Here, let's use the 35-degree angle. What do you want to solve for first?
We can do
M
M.
or
We
X?
can do cosine.
M? All right, so we're solving for m. What other side do we know?
They have
14.
The hypotenuse.
Hypotenuse. So we're looking for a trig function, sine, cosine, or tangent,
Cosine.
of this 35-degree angle that involves these two sides.
Cosine.
Cos.
That would be cosine. And cosine is adjacent, which is
Which would mean there would be M over
adjacent
14.
over hypotenuse. And again,
So the answer.
do these by putting that over 1 and cross multiply.
11.4.
So-
We've got 1 times m equals 14 times the cosine of 35.
The cosine of 35 is 0.82 if you round it.
Okay, rounded, yeah, that's fine. And 14 times 0.8 times that.
If you
is-
just leave the whole decimal, it's
11.47 rounded.
But if you don't leave it, it's 11.4.
Okay.
Well,
In
wait.
either case, it's 11.4 something.
4 between 6 to 10.
Right? Now,
Anything between them.
so you're probably getting the hang of this, right? So now let's solve for x. So we're looking for this side. We know this one. In some ways, we could use this, but this has got some rounding in the decimal.
So we can do
When,
sin.
if you, if possible, solve for each variable as best we can. So we know this angle exactly. We know this side exactly, and we're looking for this one. So
Sin.
we are looking for that relationship is this sine, because from this angle here, it's the opposite and the hypotenuse.
So
The
then,
opposite over the hypotenuse. Again, put it over 1, cross multiply. So we've got x equals 14 times the sine of 35, which is
The sine of 35 is
8.03.
8.0.
8.0. Oh, you mean it comes out to 8.03?
Yeah, in the end, but the sine is 0.57.
Okay. Alright, so there we go. Alright, so we're looking for the missing parts of this triangle. Example 44.3. A right triangle. This angle is A degrees, this angle is B degrees, this side is 7, this side is 6, and this is X. Okay? Alright, what can you tell me about the angles?
Those ones all add up to 180.
Yeah, all three add up to 180.
Well, bro.
We don't,
A plus B equals 90.
that's true.
Hey.
But we can't do anything more specific than that, can we?
Oh, yeah, I do.
What?
A equals 90 minus B.
Okay.
I solved A.
And B
Now,
equals
B
90
equals
minus
90
A.
minus
Let's go for X.
Oh, we're going to solve for X.
We can do that.
Yes, we can. Using what?
The
Pythagorean theorem.
Yes, Pythagorean theorem. So what squared plus what squared equals what squared?
A squared plus B squared, 6 squared plus X squared equals 7. Oh, that was my voice crack.
There we go.
36.
All right,
plus-
so 36 subtracted from both sides, or subtracted from 49 is what, 13?
10. No,
No, 13.
13.
13,
I
okay.
my calculator.
Square root of both sides,
I'm bad.
and X is going to be the square root of 13.
Yeah, that one.
Now we can do the negative sin. We can do sin minus 1 to find the angle.
Yes. Now, because this one here is going to be a decimal, which means that if we plugged it in, we'd have to round. You done?
Yeah.
The decimal is 3.61.
We know these two sides here.
X
If we want to solve for angle A, what's the relationship with angle A?
cosine.
Do it here. Angle A. Which relationship and what over what?
Cosine. It's
Cos.
adjacent
Cosine
over
A
It's like the
hypotenuse.
negative
Is 6 over
reverse
7.
Yes.
of cosine.
All right, so we know what the relationship is. It's a cosine relationship of the angle A is the adjacent over the hypotenuse, 6 over 7.
But we're gonna have to do reverse.
Exactly. Because we're looking for the angle instead of using the cosine. What we need to, instead of starting with the angle using the cosine function to get a number, we need to start with the number and do the inverse cosine function
58.1.
to then get the
31
angle.
degrees.
Now, what about B?
Well, you can
relation-
just, that's
what's the-
easy now.
What's the B relationship? So it's same two sides, sort of, except for angle B.
You have to use X.
Opposite over
You
hypotenuse.
would have to use sin. Or no, you would have
Sine.
no, I mean tangent.
No. So
Wait, because you would use tangent, right?
So
Well, here's a hint. Are we using the hypotenuse?
No.
yes, you're still using the hypotenuse.
If we're using the hypotenuse, that's sine or cosine.
Cosine or sine.
So if we're talking about this angle here, this 7 is the hypotenuse.
Oh, you can use sine.
Which side is this relative to angle B?
That's the opposite.
That's the opposite side. So opposite over hypotenuse, that is sine.
Yes.
Yeah.
But you gotta use the
And again,
special
since we're looking for the angle, instead of doing sine of the angle to get the number, we have to do the inverse sine of the number to get the angle.
Which is 58.1.
0.9.10.
Wait, what is it?
58.10. You can still make a name.
58.10?
Yeah.
Yeah, because it was 99 in the original. It didn't even-
997.
What was 997?
58.997 was a 3 numbers
Wait,
after.
so you round it up to 59.00.
Okay, what exactly is on the screen?
58.9.
58.997. So that actually
Bad at this.
rounds up to 59.00.
Okay.
Give.
Which makes more sense because what do you know about the angles in a triangle? They have to add up to 180. That means, and we have a right angle here, so that means that these two angles should add up to 90.
Yeah.
59 and 31 should add up to 90.
They do.
Yeah.
Do they?
That's how I knew that when you guys were saying 58, I was thinking 58 plus 31 is 89. I think there's,
Whoa, bro.
if we were again kind of like before, if we were a few hundredths off, I would understand. Okay, there was just some rounding or computation error, but a whole degree was not nearly as likely.
Wait. We don't even have to do sine. We could just do 90 plus 31.
That's true, right?
But that's rounded.
Yeah. Well, both of these are rounded.
Yeah.
Yeah, so couldn't you just do
So
that?
if you do an exact calculation, 180 minus 90 minus 31, if you do an exact calculation using a rounded number, your answer is going to be rounded.
So we can just
But
do
that's how
So
it would end up
in this,
anyways.
yeah, exactly. So in this particular problem, you had to use one of these trig functions to get one of the angles. But then for the other angle, you could either do the other trig function, or you could just say, subtract from, use addition subtraction from 180. Follow that?
Yeah.
Yeah.
So we can do
All right.
aqua.
That's the end of the examples.
Aqua.
Kill the video!